Evening. I didn't finish today's puzzle last night, and I'm gonna give it about an hour of time. I think I should be able to get there. I already have a theory of what's wrong here, because I feel like, oh, well, there goes my theory. I thought I had done this at a different place. Oh, that's peculiar. Well, I'm not sure. I've had this idea of like either if B is greater or smaller than A, then it would change where we would insert something. That did not necessarily appear to be correct. Um, so let's get the example test input in here again from this morning's puzzle. This is the encrypted file. We have it right here. Okay. AOCA. So we can see that there is one less than. Now I do also want to print the negative here. So maybe there's like one permutation that we never get to, which is greater than true. And that's the one we're messing up. I do want to print it here, and I do want to print it there, so that we can see we're actually getting the exact right permutation at the very end. 1, 2, 3. Oh, see? We're actually wrong. The very last step is wrong. So I do feel like at less than we're doing something wrong. Let's see. Um, Here, the very last one, it's false and less than. So I think here, if it's less than, we have to change something about B. I had the right intuition here, I just never executed on it. So in reality, it should be 1, 2, minus 3, 4 when we did insert it here. So why not try increasing this by 1? Now I do have a fear that we're gonna run out of bounds. Yes. Good instinct. Um, it literally says out of range, but oh, no, 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 no. It's the wrong way around. We want to insert the value I at B plus 1. Okay, so we did get out of bounds, but for the wrong reason. Now this appears to be correct. So now let's see if this is all that was needed. I'm not too optimistic. I'm carefully optimistic that this might be. Oops, what was wrong? So let's see. Let's set test string equal to empty string so that we get the real value, and then let's run this. We're too low. So actually, it might be that my second theory is also correct, that there is another edge case for LT false. Let's see. Now, the big problem is that I have no idea how to debug this because the real input is huge. It's humongous. And that's going to be really difficult to find the edge case for. I mean, it was neg false. So how about we say if and not neg, right? Because that's the edge case we had here. Hopefully, this is all it takes. And then we just turn this into an else. But I'm not too sure. Like, it's really hard to get a read on this. What answers have we given here so far? We gave 2785, which was low. The 2541 is not going to be. Oh, actually, it's the exact answer we've given previously. So that's interesting. This is not it. So one thing we might be able to do is to say neg was false. So if not neg, we do this. Otherwise, what do we do? You know, it might be plus 2. What happens now? We do AOCR. 27A5. Maybe it's -1. What happens now? 2859. Are we bold enough to try this? Yes, I'm kind of desperate at this point. Okay, that's not the answer. Well, I think at this point it's time to do a linked list. And in my opinion, well, let's commit this. I don't know what's going on with this edge case here. Let's just do this, and then say AOCR. No, GACP, not quite. So that we again have a marker for the wrong approach here. So let's create a linked list. So in my opinion, the best way to do this, just manually to say we have a L list, and for the init, we say we have an element. We're gonna do a double linked list. So we have an element, a previous, and the next. Element equals element, previous equals previous, next. Because I actually want to do a cyclic list here, and I'm not 100% sure. I think we shouldn't call it next, we should call it after, because next is a reserved word. So, this is going to make it a lot easier once we turn it into circular. So I think we can turn all of these into none to begin with. Typing is most definitely going to complain, but that's okay. I mean, look, we got time. We can just say type here int, and type here is gonna be from typing import optional, and these are gonna be optional. Yeah. Did that work? Statement none. I think this was Pylance previously offering typing. But look, let's just leave these in. It's fine. So what we're not gonna do is turn this linked list for rev equals none for lm in t current equals el list of lm rev none if prev is not none prev next current prev, and now at the very end we say start equals none, start equals current if start is false. Okay, so now we have the start of the list, we have the end of the list, which is current graph, I guess. So we can say that the start previous equals previous dot, no, it's just previous, and then previous dot after equals start. Okay, I think now we have a list which is completely filled. So let's just do a very simple print for underscore in range, and then t print start equals start dot. Let's see what this is going to do with the test input. AOCR, I can type. Cool. We probably want to define a string method for this. And return. Format string of like curly braces, brackets, angle brackets with self. Turn into a string. I actually don't know how to use the format string here to. What? How's lm? None. That shouldn't be possible. None type? Wait, what? Um, I am very confused. Why would lm either ever be none? Like I'm setting it to be number every single time I'm instantiating this thing. Um, so I feel like after is because I call it next. I knew this weird naming was going to bite me in the future. Okay. We have previous after equals current, previous. We're setting previous to previous, setting after to none. For the very last one, we're setting after to start. For start, we're setting previous. Yeah, this seems correct. Why is it wrong? Like the very second element doesn't have after that. What is happening? Why are you none? That doesn't make any sense. Start equals. Else start. Oh my god. I mean, still, this is still gonna write a. This is still gonna cause an issue. I am going crazy, and I don't know why. Ref and after. Pref and after. Elem equals elem, pref equals pref, start, current, pref equals current. If pref is not none, pref dot after current equals ul. Pref equals. I am losing my mind. String returned non-stripe non-type. I forgot. Oh boy, sometimes it's so dang easy. Okay. So now we can see that we're getting to the very last element, and hopefully, if the code is actually correct, we're going to end up at the start again. Yes. So we indeed have a cyclic list, which is double linked. So we got previous and next elements stored in there. Man, this was a nightmare. Okay. So what's next? Next is that we don't need IEX anymore. We don't need I in range anymore. I think what we need is to get the oh I think what we want is to have a current pointer, which is start, and we want to have a next pointer, which is like the following will be start dot after. And then for underscore in range len t, we say none of this stuff, value equals current dot element, and at the very end we say current equals following, and following equals current dot after. So this way we keep the position of the elements even if they completely switch order. So now we say current dot remove. No. Yes. Mhm. I think what I want to do is to store the pref and after values in the remove method so that we can keep track of them. So if we want to go down, we can still have the previous, and if we want to go up, we still have the next. Okay, so we got the remove method of self, where we store pref and after equals to self pref and self dot after, and all we do is say self pref none, self is none, pref dot after equals after, and after dot pref. Okay, and then we return pref. I think this is how we remove an element from the list. Now all we got to do is if value greater than 0, I mean, if value not equals, otherwise we don't even have to remove the element. If it's greater than 0, then we go to the right. So for underscore in range value, we say After equals after dot after. This is a little bit complex, but stick with the theme here. Then at the end we say we go to the range of minus value and we say previous equals previous dot previous. So we keep moving through the list to the right or to the left. Now once we're done with all of this movement here, we're gonna say after insert after current. Otherwise we will say previous dot insert previous. Okay, so now we just have to define these two methods, insert after and insert previous. Insert after self, new element. So what we do is we say old after equals self after, old after dot previous equals new element dot previous equals self, new element dot after equals old after. We want to set 1, 2, 3, 4 pointers, and I'm only setting 3. Which one am I forgetting? Well, self dot after. Okay, so we have this one, and then new element previous, new element after, old element previous. I think this is the most do this in. So now we do the same for previous, insert ref. We say old ref equals ref, self dot ref equals new element dot after equals self, new element dot pref equals old pref dot after equals new. Okay, I think we're ready to run a little test here. We don't need BFS in this day at all. So let's see what we get. IEX is not defined. That's correct. So what we actually want to do is find let's say a 0 element equals find no is current dot find 0 def find self value if self val equals element equals to value, return self, otherwise return self next dot find value. Okay, so we got the find going. What's your issue? Syntax error, invalid syntax. Yeah, probably. Let's just call it 0. So what we want to do is to say find print 0 plus 1000 without t plus 0 plus 3000. So this plus method we still have to write, of course. It doesn't come for free, but that will be very simple. Def plus self offset if if offset equals 0, return self column. If offset smaller than 0, return self pref plus offset plus 1. Return self after offset minus 1. So this should capture all cases. Let's see. Maximum recursion in plus. Interesting. Can it recurse 1,000 times? probably recursing it. Like, yeah, we're almost done. The maximum recursion death is okay. We have to turn this into a while loop. That's fine. Current equals self. While current element not equals. I'm fixing both methods at the same time because I'm both writing them with recursion, but wait, this work. Um cur equals cur. Okay. Because we're going like so deep into this list, so you have to turn it into a while loop. That's fine. So if no, actually let's rewrite. While offset grid 0 cur equals self, cur equals for after set minus equals 1, while offset smaller than 0, equals pref plus equals 1, return cur dot. I'm actually forgetting that. Okay. Oops, no, not correct. Has to be. Okay. 2, that's almost correct. The answer is supposed to be 3. So let's see what's going wrong here. I think we should probably write a print list method. Def print all self string for equal self dot after while cur not equal self cur after s string equals string of self while cur not equals self s plus equal cur. Okay, so now in every of these loop iterations we should be able to print all of these elements. Cool. Now the only issue is that it's completely out of order, like it's random in what order they are. They might be starting at a completely random point, but we can just find the 0 and then align them accordingly. So we start, well, I guess I should do this one time before and then after every. Okay, let's take a look, shall we? We got 1, 2, minus 3, 3, minus 2, 4, that's correct. 2, 1, this is already wrong. So we're moving the 1 between the 2 and the minus 3. Previously, between the 4 and the 2. Now we move it between the 2 and the minus 4. So my instinct is to just say value 1. How about that? Okay, so now we got 2, 1, and then 1 minus 3, 2, hopefully. Yes, that is correct. Then we got minus 3, 1, 2, minus 3, minus 3. Nope, that's not correct. Man, I'm losing track of the lines. Everything up to the last one should be corrected, but it's not. Okay, let's take a peek. We got. Look, we should probably fix this before we do anything. We got this line correct, then this line. We got 1 minus 3, 2. 3, yeah, this is correct. Then we got 1, 2, 3, 1, 2, 3, Minus 204. 1, 2, 3, minus 3. Oh, this line is wrong then. Yeah, totally wrong. Completely wrong. Totally off. Ah! Okay. Minus 3 moves 0. Why do I have a feeling that I'm not moving minus 3 at all? Oh boy. We need a new array. So we got all nodes equals earned dot lm list. For node in all nodes, current equal node value equals current dot element. None of this following BS. None of this cur BS. And we only have to write this method. Def all lm list of self L equals empty, return L, C equals self, while C is none, L up C equals dot after. Now this should work. C dot. Okay, I guess we always have self, so we should start with after. And we should do this just like we've broken it up. Okay. Is it working now? And can I finally remove the +1, -1? We got 1 minus 3. Oof. I mean, I guess it's just offset. 1 minus 3, 3 minus 2, 0, 4, 2. Perfect. Then we got 2, 3 minus 2, 3 minus 2, 0, 4, 1 minus 2. Perfect. Minus 3, 0, 4. Oh, this one is wrong. One moves, 2 moves, minus 3. So when the minus 3 moves, we're fucked. Minus 3 moves between. Okay, wait. We got line 1, 2, and 3 correct, and then 4 is wrong. 1, 2, 3 correct, 4 is wrong. Because it moves between 2 and 0. Well, it totally did not do that. It moved 1 too far to the left. Ain't that interesting? Well, my theory is that I just have to remove the +1 here. Right? 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 Yeah. Now the minus 3 moves between. No, it does not. Ah, it didn't change at all, did it? No, it did change. Did it? Kinda. Fourth line was this. Now it's this. What changed? Um, I guess it has to be -1. So that's crazy. Total cray cray. Yeah, but it's working. Okay. What's really fascinating to me is that we've got the same output 3 times. Okay. Are we getting the right thing at the end now? 1, 2, minus 3, 4, oh, 3, minus 2. Yeah, pretty happy. The final answer is 3. Again, like it always is. So let's just remove all of the print alls. Well, maybe not the definition of it, but all executions of it. And attempt solving this one. I have a pretty good feeling now. Not correct. Shh. Ah! Now we gotta wait a minute. Oh no. Well, how are you doing today? How's it going? Yeah? No way. Wow. What a story. I could be working on one of the other 2 days, but unfortunately, I really have no idea how to approach either of them. There's the day with the traveling salesman problem, where I'm still to fully understand how dynamic programming works yet again. I've known this before, but it eludes me at the current moment. I do remember that you have like 3 different things you compare. You have a table, you have a field in the top, you have one to the left, and you have one to the top left, like a square of 4 table values. So you're trying to fill out this little one, and you're comparing it against this little one up here, and this little one, and this little one. And for all of them, you're adding 1 for the distance from the graph. And then once you've done that, you find the minimum and you put it in this column. And that's how you get to final result, by filling out this table element by element by element, going through every row, through every column and every row, row by row, column by column. But I need to know the exact formula in order to be able to change it, so that we also remember not just the minimum distance, but also the what else do we have to? Oh yeah, not just the minimum distance, but like the summed up released steam over time, by remembering what flow we've already opened. So it's not just a plain a little bit more. Explaining all of this took about 3 minutes and 73 seconds. And we had about 2 minutes and 18 seconds. Oh, let's play a game of Online Snake. Actually, I want to play some online Tetris, but Tetris Online has been taken offline, which is really sad. Tetris. I really hope it doesn't have any music. Hopefully it doesn't. Okay. No, it doesn't anymore. How do how do I turn it the other way? I just turn it one way? No, sucks. How do I hold? I should learn the controls. Ah, enter. Shift. C. C is hold. Of course it's. If C is hold, maybe I'm fine just spinning one. I haven't played Tetris now. So you can. Thrilling content. Not even a full Tetris. I knew how to do T spins at some point, but can't remember. Definitely. What? Thrilling content. I know. I should really be talking more because of stream. Mad props to all these streamers to do this kind of stuff for for a living. I could never. Anyway, I think we're pretty much done here. Could be playing this forever. The speed is not increasing whatsoever. Okay. I mean, we screwed it up, but I want to prove that I'm able to get myself out of it and then do it. Yeah. Okay. We're not going to do this anymore. We're definitely due for a solve. Woo! Correct. Part one complete. Only 5 minutes too late. What's next? First, you need to apply the decryption key. Multiply each number by the decryption before you begin. Okay, that's fair. Um, so let's just copy all of this stuff. Then we say this. Then we actually do this. Is mod a defined function? I don't think so. Because we need to do like a changed modulo because I still want to go left and right by the exact steps and I don't want to change the sign. So while x greater than len of t minus 1, this is the key part that I messed up before, I think. Greater than this plus 1. Okay, no. This is the way I want to write it. Okay. X minus equals if smaller than minus 1, x plus equal. Coolio. So now, god damn it. Now the problem is that the final thing. So how about we don't do the mod here? We do the mod somewhere else. Where do we ever need LM values? Ever need them down here? I think this should work, right? Right? I mean, it's going to be a little bit longer, but it's going to take ages. Dang it. Look, this is extremely inefficient, not because this is an order of magnitude in the wrong in the complexity. It's simply because I wrote this double linked list myself, which is never going to be. I also feel like to really do this differently. So how about we store both? We stored the value and the mod. So this has lm and mod. So this way I only have to compute it once. That's gonna help a lot. Let's see how long it takes now. Oh my god, why is this taking so long? You're going through 23,000 values. That's not that many. And how is 23,000 even a valid value? Like, you multiply it by this much. Crazy? Oh, this is the output of the previous. Subtracting like the length of this stuff being so long? Like, how long is this? 5,000? I mean, how often can you subtract 5,000 from it? A lot. Maybe I do have to use the modulo function. Ah, okay. We need to fix this modulo. But the thing is, like, it still should be negative, right? Right? So the sign was -1 if smaller than 1. Okay. If x equals 0, return 0. Sign equals -1 if x smaller than 0, else 1. So now we just do mod minus or plus n. How about that? And it's really important that we don't return 0 ever. So I'm feeling like maybe, okay, anyway. Um, if x smaller than 0, then return x modulo n. Where did n go? N is gone. If x smaller than 0, return x modulo n minus n. Otherwise, return x minus 1 modulo n plus 1. Yes, I think. Sure. Find out. Oh, simple. Easy. Is it possible that it's negative? Sure. Why not? Let's try to solve this. Hmm. That's not great. That's not great. So, here's my theory. The mod fucked it up. Oops. Is this correct? I think so. Is this correct? I think so. I mean, let's just test this. How about that? My fear is the following. If I write this method, yes, I do want to fetch this, and we do like mod 5, it should never return 0. Never return 0 because we're moving stuff. And if it's 0, then we're doing like a different logic here. Next up, what if it's 6? Then we should actually return 1. Awesome. What if it's 0? Then we should return 0. What if it's -1? Then we should return -1. What if it's -6? We should return. So I think my mod function works the way it's supposed to work in my head. Now, is the way it's supposed to work in my head the way it's actually supposed to work? Amazing question. Let's read through this entire part again. You need to apply the decryption key. Multiply each number by the decryption key before you begin. This will produce the actual list of numbers to mix. Secondly, you need to mix the list of numbers 10 times. The order in which the numbers are mixed does not change during mixing. The order in which the numbers are mixed, numbers are still moved in order they appear in the original. Okay. Why did I not read that line? Times 10, Python to the rescue. Um, I mean, this is not gonna run for crazy long. Like, sure, it might take a couple of seconds. Um, yeah, I think I want to solve. Yes, awesome. Okay, part 2. I'm pretty happy with today's puzzle. That was fun to figure out. You know, you had to write your own little linked list. You didn't, probably, if you did it properly. I did. It worked out fine. Um, I'm happy with the little modulo. It's important that you don't ever return 0 if the input was not 0, which is what I tried to do here. It's important that you always return a negative value when you put in a negative value, which is what I, tried to do here. Yeah, it's important that you know that you have to do modulo by len -1 because you're removing an element. And then wrapping around the list all over again. Really happy with this. I'm pretty sure this is like a reference implementation, except for I have no idea what's going on here. Don't ask me. Um, and also, I have no idea why it's so damn slow. Well, I do have an idea why it's so damn slow, because I wrote my own little list implement. And it would be way faster if I would use this, which is a pre-existing list that I already imported, but I don't really 100% know how to properly use. And plus, wouldn't have had this cool little mod that we were able to add in the second part. So yeah, let's end the stream here. I'm going to take a 5-minute break, and I'll be back for day 21.